All right, good morning. How's it going today? Good, going well. Awesome. All right, well, so any questions on the ODP yesterday? There was a lot of confusion. There were a lot of people who did not look at the return value from scanf, or things like that, or did not use the second argument to pick up extra stuff after an integer. So any questions in the end of that? I haven't looked at the submissions yet. I looked last night, and it looked like a lot of people were getting this successfully turned in, so I'll look at the scores later. Yeah, we can talk about fgets today. What do you want to talk about? And a question on homework for, okay, hold on one second. Let me take a look at one thing on Canvas. Alright, so ODP 413 is open right now. In Canvas I said 412, but 412 isn't up there. So I'm going to change Canvas to say 413. And go ahead and do ODP 413, not 412. We're skipping 412 for now. And we're going to talk about 413 today. Alright, so 413 is live. One person already did it. Let's talk about fgets, and then, well, go ahead and ask your question about homework 4 first. Let's talk about the specifics first, and then we'll talk about fgets, and then we'll talk about the current ODP.
The number saved in argv and assign it to a variable, because like I try to just do like int variable and then equals argv, and it throws like a warning that says that it's a pointer, like it's trying to assign a variable, like an integer from a pointer.
Okay.
How would I actually access that so that I can use that number that's inputted in argv throughout the rest of my program?
Okay, good question. Did our discussion about that yesterday make any sense? Or should I just start from the start?
I mean, yeah, I believe it made sense, but now I'm questioning whether or not my understanding of it is entirely as accurate as I previously had thought.
Okay. So let's run through that. So you write your main program. It's got 2 arguments. Right, argc, argv. If you run your main program with, say, main hello 12. Okay, there's 3 things on here. argc is going to be equal to 3. And you'll have 3 strings called argv bracket 0, argv bracket 1, and argv bracket 2. And in this case, argv bracket 2 would be 1, 2, argv bracket 1 would be HELLO, argv bracket 0 would be MAIN. Okay, so argc tells you how many of these things you have. And let's say, you know, that you're supposed to run main and this third argument is supposed to be an integer. Okay, so here's what you do. See if argc is at least 3. Okay. If argc is only 2, this is not available. If argc is only 1, neither of these are available. Argc will never be 0. But we want to look at argv bracket 2. Don't look at that until you check argc first. Make sure argc is at least 3. If it's bigger than 3, it means you have other stuff. But if it's less than 3 and you try to do anything with argv bracket 2, you might seg fault. Okay, so that's the first thing. Make sure that argc is big enough to say, okay, argv bracket 2 has a value in it. And if that's supposed to be an integer, then you do something like, you know, return value equals scanf argv bracket 2, because that's just a string, %d, address of num, where num is an integer, and return is an integer. Okay, you're not ready to use num yet. You have to check the return value. See if the return value is equal to 1. If not, don't use num. Okay, see if arg3 is bigger than or equal to 3. If not, don't touch argv bracket 2. Okay, that keeps you from seg faulting. Scan argv bracket 2 as a %d, save the result in num, save the return value from scanf in an integer, check that integer, make sure it's exactly equal to 1. If it's not, don't use num. It's not the value that was given on the command line. Okay? The only time you know that num represents the integer value of this argument is if argc was at least 3, right, and you did this scan and your scanf returned exactly 1. Then and only then is num the integer that corresponds to that argument. Right? So you gotta earn the right to use that variable. Right? You gotta make sure all these things are in place first. Once you've got through that, and you've got through that, and you've done your scan, then num's just an integer, and in this case it would be equal to 12. Does that help?
Yeah, that clears it up actually. That's
Okay.
literally the missing piece, the num part from scanf. That's it. All right, thank you.
Awesome, perfect. You're welcome. All right, does homework 4 need to include the new feature that we used in ODP 411? You mean 411B? So homework 4, in the README, it says that if it says, you know, how many sticks to take, if the person says 3, haha, you're allowed to just use the 3. Okay, so you don't need to use this latest trick we talked about yesterday of using the %s after the %d. Just scan with a %d. And if it says you got an integer, you've got an integer. Okay, that's for how many sticks you want to take. And also for the number of sticks. I'm not going to test it with something like this, so if you pick up this case as an error, your code's going to be fine. If you pick up this case as just the number 3, your code's going to be fine. Okay. But remember that if you specify the number of sticks on the command line, and you say something like this, that is an error. Okay. When you specify the number of sticks on the command line, you're only allowed to have one argument, which is the number of sticks. If you have another argument, right, this is not a question of using that trick for scanf. This is a question of looking at argc. Make sure argc is either 1 or 2. Anything other than that, it's an error. And for the number of sticks, is that okay? Yeah, it's totally fine. Like I say, I'm not going to put in this for, you know, how many sticks to take. Or when the program's running, if it says how many sticks do you want to play with, I'm not going to say 3, haha. I'll just give you a number, or I'll give you just haha. Alright, but if you're expecting a number and the person types in something that's not a number, if they just hit enter, if they type in you know, a bunch of spaces and hit enter, if they type in something that starts with a letter, right, that's an error you need to pick up. Alright, so someone said argv is a pointer to an array of strings, pointer to a character array. Yeah, so argv is a pointer to an array of strings, exactly. So argv bracket something is a string. It's an element of that array. Alright, let's talk about fgets, and then we'll go to the ODP. So fgets, not a whole lot to worry about with this. Fgets, you pass it 3 arguments. The first argument is the name of a character array, or what we call a string. The second argument is an integer, which is the length of that string. And the third argument for now is always going to be standard in. And this will read from your keyboard, right, or a file if you redirect, until you hit the enter key. When you hit the enter key, it will take what you typed in and store it in this string. And if what you typed in was longer than length of string minus 1, it will only take the first length of string minus 1 characters, store those in this string, put a null terminator on the end. Okay, so you can't overflow this string with fgets. Right, but this is basically how we call it. So let's look at that. Right, so easiest way to learn about a function is to write some code that uses it. Right, so it's that straightforward. Now let's do something else. Let's take a look at the return value from fgets. And we don't need this for homework 4 or for the ODPs, but this is something we'll need down the road. Fgets actually returns something. So let's look at the manual page for it, and the manual page covers a bunch of things. Okay, here's the fgets we're playing with. It takes a string, character pointer, the size of that string, a stream, which is what standard in is. It returns, what? A pointer to a character. Alright. And fgets reads, you know, at most 1 less than size characters from the stream, stores them in the buffer. If a new line is read, it's stored into the buffer. We discovered that yesterday. A null terminator is stored as the last character. Return value. Fgets returns the string that you pass to it on success, and null on an error or when end of file occurs. while no characters have been read. Okay, so fgets will return either the string that we pass to it or the value null. So let's save the result of fgets. Alright, so we'll have this variable called result, which instead of being an integer is a pointer to a character. And let's just say result equals. And let's print out the value of result. And we'll print it as a %p. And let's see what's happening here. Alright, so if I say hello, it tells me that the return from fgets was this weird hexadecimal number. And the string was equal to hello. If I run it again and I say hello, the return from fgets was some slightly different weird hexadecimal number, and the string was equal to hello. And if I just hit the enter key, my result from fgets is another weird hexadecimal string number, and the string is just empty. It's a new line. Alright, so now I'm waiting for input from the user. I'm going to hit Control D. Okay, this is how we signal end of file in Unix. So I'm going to hold down Control and press D. And now the result from fgets, it says, is nil. That means it's null. %p prints null as NIL in parentheses. So this is a hint to us, right? We can call fgets, and if it does not return null, we know that we read a string from stdin. So we can cobble together a loop and so I'm calling fgets, and I'm going to take the return value from that, and I'm going to say, is that different from null? And if it is, I'm going to execute the body of this loop, which is going to print out the value of result, which will be pretty uninteresting, and it'll print out the value of the string. And then it will go back up to the top of the loop, which will do what? Well, it will try to evaluate this condition, which means it has to call fgets again. So it'll call fgets, which will wait for me to type something in. And then when I hit enter, or if I hit Control D, right, it'll take the return value, compare it to null. If I type something in, or I did not hit Control D, this will not be null, so I'll go ahead and print out result in string, and I'll go back again. So we're making a loop here, which loops until we hit end of file. So I can say hello, and there's, oh, I didn't use result anymore. So let's just get rid of result. Alright, so I can say hello, and there's hello. This is fun. I can hit an enter key. I can type in numbers. When I'm done with input, what do? I hold down Control and I press D, and that's the end of the file. Alright, we also talked a little bit a few weeks ago about input redirection using a less than sign. We said that we could run a command less than sign the name of a file, and it would read stdin from that file. Instead of fgets reading from my keyboard, it will read the contents of that file. So I can say test file. Alright, so here's a file. And if I run fgets less than test file, He gets the input from the contents of that file. And this is really useful when you're debugging code. If you have, a certain set of input that causes your code to break, you can put that input in a file, and now you can reproduce that error condition by just running your code, but redirecting the input from a file. And if I redirect the source code to fgets into fgets, I just get a copy of my program. And if I do an ls and I pipe that into fgets, fgets will now read stdin as the output of the ls command, and my program now shows me line by line the contents of my current directory. So this one call, right, is a way typically to read input from the keyboard, but it lets us do a whole lot more, right? It captures input from whatever we're using to supply stdin, which could be a file, could be output of a command, could be the keyboard, could be other things. All right, other questions on fgets or other stuff? All right, let's talk about the ODP. All right, so 413, totally unrelated to what we've been doing so far. So ODP 413, you're writing a function called count_e. It takes an array of characters, that's a string, and returns an integer. And the integer is the number of times we find a lowercase e in this string. So make a for loop, loop through the characters in the string. Each time you find the letter e, increment a running counter. When you're done, return that count. All right, so we'll talk about the string length function in a moment, right? As one way to know how many characters are in the string. If you use string length, you want to include string.h in the beginning of your function. Write your own test bed, right? So call count_e with different strings, look at the value it returns in each case, and make sure that's the number of e's. Link up your test bed like this. Make sure that your function seems to work. And then to assess it, go ahead and link it in with the test bed. So here I'm calling my main program count_e. And so I would assess count_e and then the name of the source file. All right, so let's talk about strings and string functions. So there's an include file string.h, which gives you access to a whole bunch of functions for examining and manipulating strings. The main one we care about right now is called string length. In string length, you pass it a string, and it returns an integer, which is the number of characters in that string. Okay, so what is a character? Let's find out. right, so test code. I started taking attendance, by the way. I had a few minutes spare time last night, so I wrote a script that wakes up every 10 minutes and does a screenshot of the participant window from Zoom, and then runs it through an OCR, turns it into a text file, timestamps that, and saves it, and then I can go through and I can crunch those and see how many times during the class each person's name showed up. So I'm not going to take off points for attendance at this point, but I want to know who's here and who's not, so I'm scraping that data. And it's a cool bash script, so yay for bash. Alright, so let's compile S1 and let's run it. We're looking at the string length of quote HELLO. Let's run that. String length returned 5. Alright, so HELLO, 5 characters, that's what string length returned. That looks pretty reasonable, right? If I say HE and I put a space in the middle and I say LO and I run that, string length is still 5. If I have 2 spaces, the letter X and a space, it returns 4. So string length is pretty unambiguously just counting how many characters from the beginning of the string to the end. Alright, we always want to play with edge cases. That's where life gets interesting. So let's try an empty string. String length is 0. Alright, so we have quote hello, 5 characters. This is character bracket 0, 1, 2, 3. This is character bracket 4. String length equals 5. The last character is character bracket string length minus 1. That's useful to know. Alright, the last character will be indexed by the string length minus 1. And we know that in fact there's a null terminator at the end of this. That null terminator is at position index string length. And if we counted the null terminator, we'd find 1, 2, 3, 4, 5, 6 characters in this array, including the null terminator. But string length does not count the null terminator. Okay, it only counts the HELLO. So those are edge case details to keep in mind. Write some code, come back to it if this seems like it's tripping up. Alright, so let's play with this. Let's make a character array. And let's prompt the user. So we'll ask them to say something. And let's use fgets. So we'll read 120 characters from standard in. And let's calculate the string length of that. Alright, so say something. I'll say hello. String length returned 6. Alright, why is string length of hello suddenly 6? Extra space, almost. What kind of space? Yeah, there's an extra new line at the end. Because fgets always appends that new line at the end of it. Just for kicks, let's do an fgets string length, and let's tell it that we only have 5 characters available. This is okay, right? I've actually got 120 characters available. If I tell fgets I only have 5, that's not a problem. If I tell it I have 120 and I only have 5, that's a problem, right? That's going to overflow things. But I can tell fgets, yeah, there's only 5 spots available. That's totally okay. So let's run S2. If I say hi, string length is 3. If I say this is a very long line, what is string length going to be? Five or error. Reasonable. Other answers? Only one answer. 4. 5 question mark. 5. I mean, it seems like it could be an error because our string is too long, but fgets will behave correctly with a long string. It will simply absorb part of the string that fits. And we've told it that there's 5 spots available in this array, so it should use all 5 spots. But remember, fgets is going to store a string, which means there's going to be a null terminator on the end. So even though we tell it this array has space for 5 characters, it's only going to read the first 4 characters, THIS, store those in string, and then the 5th spot in string will be where the null terminator goes. So our string will be THIS, string length will be 4. And so I've seen people get into trouble by doing this, thinking they only want to input 1 character, and so they set up string length to read 1 character. Well, it never waits for me to type anything, because whatever I might type, there's no place to store it. Because if there's only 1 byte available in the string, that's got to be used for the null terminator. And so fgets returns immediately. It doesn't wait for me to say something. Alright, in general, just make this big. Make your arrays big, give fgets access to that full array, and then you know, if you type something reasonable, it'll just ingest all of that. Alright, so how do we iterate over a string? We can just use a plain old for loop. So we'll leave our character array here. We'll leave I for the string length. We'll prompt the user. We'll get something. We'll get the string length. So let's do this. Let me say iterate over the string. And let's look at each character. So here a for loop works really well, right? For loops work well if you have access to a number that tells you how many times you want to loop. That's when you think for loop. If there's a condition that says, you know, I want to loop while this condition is true or false, go with a while loop, okay? I suggest not coding while loops as sneaky for loops where you have strange initialization and termination conditions. It works, it's going to raise eyebrows in the future, right? If you want to loop until some condition applies, use a while. Reserve for loops for when you know I want to do this 5 times, 10 times, n times, I times, right? That can be a for loop structure. So here we want to loop over each character. How many characters do we have? We have I characters. Okay, So integer index equals 0, index is less than I, index plus plus. Alright, if I is the string length, why am I doing index less than I? Because the last character will be indexed at string length minus 1. Okay, if string length is 5, the last character I want to look at is index 4. So I want my index to run from 0 on up to the point where it's less than string length. Okay, or if you like, less than or equal to string length minus 1. So it goes up to and including string length minus 1. So let's just look at the characters. Character %d is, and I'll go inside angle brackets and I'll just do a %c. And I'll print out index, and I want the character indexed by this variable index. That's just the name of the array bracket, and then the index variable. Right, so once you have an array, you can pick off the individual elements by just addressing it in brackets. And I'll just print an end of string message at the end. Alright, say something. Let's say hello. And there's what I get when I iterate through. Character 0 is H, 1 is E, 2 and 3 are L, 4 is O. Character 5 is, well, that's what a new line looks like if you print it inside angle brackets. It went down to a new line, and that was the end of my string. Alright, so characters are different from strings. If I say quote O, right, this is a string. A string is the same as an address. If I want to talk about the character O, I have to use single quotes. Single quotes say, I'm talking about the ASCII code of this letter, or this symbol. So let's say we want to know if the letter O occurs somewhere in our string. So we can do something like this. If string bracket index equals the letter O, let's just print a message. Alright, so string is an array of characters. If I pick off an element of that array, like string bracket index, that is a character. Okay, single quote O, single quote, that is also a character. So these are comparable. So this would check to see if each character in the string is equal to the letter O. So, hello there, oh wow, cool, so hello, and after it printed the O, it said I found the letter O, and there, O and OH, and I found the letter O, and so on. You get the idea. Alright, now if you try to do something like this, and you try to compile that, you'll get a warning. Again, pay attention to warnings. They're usually not something you can safely ignore. The warning here is actually meaningful. It says comparison between pointer and integer. Okay, what the heck does that mean? Well, a character is actually an integer. It's a small int. It's an 8-bit integer, so something from 0 to 255. And so your messages here won't say character, they'll say integer. It says, I'm doing a comparison, that's my double equal, it's pointing to it. And one side of the comparison is an integer, that's the character. The other side is a pointer, that's this string. Because strings are pointers. Alright, and you can't compare a pointer and an integer directly to each other. You can, but it probably means that there's something wrong. Right? Pointers are really just big integers, but it's saying this looks suspicious. Okay, that's basically how you can interpret warnings. So change that to be a single quote. So now we have a character on the left side, a character on the right side, or if you like, two integers, and the warning goes away. Alright, paying attention to these will save you a lot of time sometimes. Alright, questions on any of that? That's a lot of stuff, but that's more than enough to be able to do ODP 413. Okay, because basically your count E function needs to iterate over the characters in your string that you passed in, right, which is going to be a char star, but that doesn't change how you index it, that doesn't change how you pass it to string length, and so on. And so set a running counter to 0, go into your loop every time you find the letter E, increment that counter, and at the end just return that counter. And if there are no E's to be found in here, your counter will have its initial value, which was 0, and you'll correctly return a 0. If there are no characters in the string, your for loop will never execute the body of the for loop, and your running counter will end up with its initial value, which was 0, and again you're returning the correct value. One of the best feelings in coding is when you think about how to implement an algorithm, right, and you come up with pseudocode or maybe actual code for it, and then you start working on edge cases and you find that your code still works, even for those edge cases, right? That's an indication that you actually thought deeply about what the goal of the problem was and came up with a good solution for it, right? And that happens more and more over time. And it's really fun when your own code can surprise you. And it's like, oh, I didn't know it would do that, or I didn't know it would handle that case, right? That's kind of a cool feeling. All right, so no questions on this? All right, well, we got about 5 minutes. I'm going to go back to talking a little more about VI. So let me see where we left off. All right, so we had finished talking about deleting. Let's make a test file. So I can post this code later. All right, so here's my test file, 21 lines of glorious C code. So let's talk about miscellaneous things. So we talked about deleting. I said you can delete by saying dd, right? And that removes an entire line. And it doesn't matter where you are in the line. You could be in the middle of it, and dd will just take out that whole line, move everything up or down. All right? When you delete, the thing you delete actually goes into something like a clipboard. It's called a yank buffer. and it's sitting in there, and if I wanted to put that line somewhere into my file, I can move to wherever I want it, and if I hit a lowercase p, that means put, it'll put my line right there. And if I want to move it somewhere else, I can say dd, and I can come down here and type a p, and it'll put it right there. And if I want to put it before a line, and this is really only an issue if you're trying to put before the first line, I can do an uppercase P, and it'll put it before the line that I'm currently on. So lowercase p will put it after, uppercase P will put it before. And if you do 15p, it'll put it 15 times. So if you really want to stress something, you know, or do something a bunch of times in a row, you can do that. And this happens a fair amount, right? I might want to do these three statements a bunch of times. So I could say 3dd to delete them. I could do a p to paste them, right? Or I could do, you know, a 10p to paste that set of three statements 10 times. And I just wrote, you know, a 30-line program without a whole lot of work. And without having to mouse down and do control right click and hit paste and all that kind of stuff, right? So very short commands. And another way that you can yank stuff into the yank buffer is just by using the yank command. So for example, I could have said 4 and a shift Y, and it'll say 4 lines yanked. And now I can do a shift P and paste it above my current line, right? And I can do that a few times, or I could have said, you know, 10p to paste it 10 times. All right. So we've got a clipboard, right? And anything that you remove automatically goes into that clipboard. So if I delete word on my printf and I come down here and I say p, it puts my printf right there. And if I say, you know, let's get rid of 2 words, and I come down here and I do a P, it'll paste it right there. All right. So these take some playing around to get used to. Mostly I use this for if I delete something and I paste it, right? So usually it's for moving lines around. And a lot of times that's for cosmetic stuff or changing the order of things. All right. Along those same lines, Shift J lets you join 2 lines together. So let's say I wanted to put these 2 lines on a single line, Shift J will join them. All right, and then I could take that and I could repeat that a bunch of times. Or I could join all 3 of these together and yank that and paste that, or paste it somewhere else. All right, the other one, I don't know if I mentioned this, but period repeats your last command. So if I want to delete a line, I can come up here, I can say dd, that deletes the line. If I want to delete the next line, I could say dd again, or I can just hit a period. And period repeats whatever your last command was. Right, so if I want to delete a word, I can do dw. To delete the next word, I can just keep hitting period. Shift J will join. If I hit a period, it will join again. If I want to turn my whole file into a single line, I could do, you know, 1000 Shift J, and now my file is a single line with 1100 characters in it. This won't compile. If I want to undo that, I can just hit a U. All right, so we're out of time there. So bring questions. We'll talk more about VI tomorrow, but bring questions on homework and such, and I will see you then. All right, bye.